The fifth and sixth terms of an arithmetic sequence are 14 and 17, respectively. What is the 40th term of the sequence? Let's go. All right, so there's two types of sequences that you need to know on the ACT and the SAT. Those two types of sequences are arithmetic, which means you're going to add or subtract the same number every time. So plus 5, plus 5, plus 5, plus 5, for example. That's one type, the arithmetic type, where you're adding or subtracting the same number every time. Or geometric, where you're multiplying the same number every time. So times a half, times a half, times a half, for example. Okay, so you need to know arithmetic, you need to know geometric. You need to know the difference. Those are the only two types of sequences you got to know. Well, they tell us in our case that we have an arithmetic sequence, which means that we are adding the same thing every time or subtracting the same thing every time, same difference. But the fifth and sixth terms of our arithmetic sequence are given, and those are 14 and 17, and they want the 40th term. So you might be thinking, well, do I need to know a formula? Do I need to know some weird process to get there? You don't really need to know a formula. You don't. I think what's better is to understand what a sequence is and then start to map out the terms so you can see the pattern for yourself, because it's pretty simple to do. We know the fifth and sixth terms. So what I'm going to do is I'm going to map out 1, 2, 3, 4, 5, 6 spaces representing my terms. And I know that the fifth term is 14. And then, that's a funny looking 4. And the sixth term is 17. And I know those because that's what they told me. But I don't know what the 40th term is. So we're going to have a bunch of terms, ... And eventually we want to find our 40th term. Okay, so here's our fifth term. Here's our sixth term. We want to find our 40th term. How do we get there? Remember, an arithmetic sequence means we're adding or subtracting the same number every time. And very clearly in our sequence, we are adding 3 every time, right? Because 14 plus 3 gives me the 17. So the strategy I like for this problem is to say, well, let's just figure out, without using a formula, let's go back and figure out what the first term would be. And then let's see if we can come up with a method to get that 40th term without doing it the long way. I mean, we could mash buttons in our calculator and eventually get there, but you might lose track of exactly what you've done. So let's find a more elegant approach. If I backtrack by 3, that'll be 11 for the previous term. So the fourth term was 11. If I backtrack by 3 more, then we're back to 8. If we backtrack by 3 more, then we're back to 5. And if we backtrack by 3 more, then we're all the way back to 2. So what that means is our first term was a 2. Now let's think of it this way. How many jumps did it take me to get from my first term to a second term? It took 1 jump of 3. How many terms did it take me to get from my first term to my third term? It took 2 jumps of 3. So it was like a plus 6. So the first one was a plus 3, the second one was a plus 6. To get to the fourth term, how many jumps did it take me? Well, it took 3 jumps to get there. So that was a plus 9. To my fifth term, it would take me 4 jumps. So that would be a plus 12. And let's just check it. 2 plus 12. Well, that's a funny looking 2. 2 plus 12 gives me the 14. So see, what's happening is here, the term number minus 1 gives me the number of jumps that it takes for me to get there, right? So the term number, 5, minus 1, that's 4. It takes me 4 jumps to get to that term from the starting point. That's the trick. So if I want to get to the 40th term, how many jumps would it take to get there? It would take 39 jumps to get all the way here. So if I do 39 times 3, that'll be the amount that I have to jump by to get to the 40th term. 39 times 3, you can use your calculator if you need to. This is 117. So if I take 117 and I add that on to 2 plus 117, that gives me 119, and my 40th term is therefore 119, and I didn't need a formula to get there. So that means our answer is A, and if you got it, good thinking.